Hello students, I am Kinjal Parmar. Welcome back to the video lecture series of microprocessor and microcontroller. Today we will discuss AVR External Interrupts. So let's start with what is external interrupts in AVR. The number of external hardware interrupts varies in a different AVRs. The 8MEGA32 has 3 external hardware interrupts pins: PD2 that is port D.2, PD3 port D.3 and PB2 that means port B.2 designated as INT0, INT1 and INT2 respectively. Upon activation of these pins, the AVR is interrupted whenever it is doing and it jumps to the vector table to perform the interrupt service routine. This AVR external interrupts are 3 types of hardware interrupts in 8MEGA32, that is INT0, INT1 and INT2. They are located on the pins PD2, PD3 and PB2 respectively. The interrupt vector table location of this INT0, INT1 and INT2 are 2, 4 and 6 in a hex respectively. The hardware interrupts must be enabled before they can affect or they can take any effect. So this is done using INTX bit located in the GICR resistor. Now what is GICR resistor? So let's discuss about GICR resistor. So GICR resistor is a resistor in which there is an external interrupt pins, that is INT1, INT0, INT2, 3 unused pins and IVSEL, IVSE. So first is INT0, that is external interrupt request 0 enable. So if this one is 0, then disable external interrupt 0. If 1, then it is enable external interrupt 0. Then next is INT1. INT1 is for external interrupt request 1. If 0, so interrupt is disable. 1, that means interrupt is enable. Next is INT2, that is external interrupt request 2 enable. If 0, then disable. 1, that means enable. Then next here these bits along with the I bit must be set high for interrupt to be responded to. There are 2 types of activations for the external hardware interrupts, that is level trigger and age trigger. INT2 is only age trigger while INT0 and INT1 can be level or age trigger. So this INT2 and INT0 upon the reset INT0 and INT1 are low level trigger interrupts, and the bits of MCUCR resistor indicate the trigger option for INT0 and INT1. The ISC2 bits of the MCUCR resistor defines whether INT2 activates in the falling edge or a rising edge. For an external interrupt, there is a controller resistors, the names of MCUCR and MCUCS. So upon reset ISC2 is 0, meaning that external hardware interrupt of INT2 is of a falling edge trigger. So here we have a MCUCR. So upon that there is a bit ISC11, ISC10, ISC01, ISC00. So these are bits for this INT1 and for INT0. First is ISC01, ISC00 interrupt sense control bits for INT0. These bits define the level or a age on the external INT0 pins that activates the interrupt. So whenever it will 00, then low level of INT0 generates an interrupt request. If 01, then on any logic change on INT0 generates an interrupts request 1 0, then falling edge of INT 0 generate request 1 1, then rising edge of the INT 0 generate an interrupt request. So this is about INT 0. Now next is for INT 1. So here ISC 11, ISC 10 interrupt sense control bit. These bits define the level or the edge that activates the INT 1 pin. So 0 0, then low level of INT 1 generate interrupt request 0 1, then any logic change of INT 1 generate the interrupt request 1 0, that means falling edge of the INT 1 generate request 1 1, that means rising edge generates the interrupt request. Now next is a MCUCSR. So in that only one bit is related to external interrupt, that is ISC2 interrupt sense control bit. This bit defines whether INT2 interrupt activates on the falling edge or rising edge. If 0, the falling edge of INT2 generate the interrupt request. If 1, then rising edge of the INT2 generate interrupt request. So this all are the INT2 and INT1 0 bits informations. Now here we have a AVR external interrupt programming. Assuming that INT 0 pin is connected to a switch that is normally high, write a program that toggles port C.3 whenever INT 0 pins goes high. So how we can do this? So here we have a one program that write first include to add a library of 8mega32, then ORG0 jump to the main locations and ORG02 for external interrupt 0 vector locations. So here if we jump at the ISR, so it will jump to the interrupt service routine program, and if it executes, so first main program. So in a main program we have to just toggle the port C.3 when INT 0 pin goes low. Okay, so whenever we want to toggle the pin, so here we can store the first content on a stack pointer. So stack pointers are stored over here, then make a port C.3 as a output, then activate only set that bit. So SBI DDR C.3 and SBI port D, 2, so pull activated, then LDI R21 less than INT 0. So whenever INT 0 is equals to 1, we just calculate the values of GICR register. So we make this GICR register is equals to R20. Now to enable the interrupt, we set interrupt enable over here. So use SEI instructions. Now whenever this set is executed, so it will jump over here and here again. But whenever INT 0 is activated, then interrupt service routine is executed, and in a interrupt service routine, it read the pin C and copy this data. Okay, whatever the content of it is copied into R21, and this load the data, and it will toggle only one value. So it will toggle only third bit. Okay, that's why it is written R22, 0x08, and then perform XORing operations and then toggle that when it is 0 AE or operation. So for 0 0 and for 1 1, it will remain the 0, and for other operations 0 1 or 1 0, it will retain a 1. So this values is sent on a port C, and after execution is returned to the main program after TI instructions. So this all the performs this kinds of external interrupt programming. Here we have external interrupt programming in a C format. Assume that the INT 0 pin is connected to the switch that is normally high. Write a program that toggle port C.3 whenever INT 0 pin goes low. Use the external interrupt in a level trigger mode. So for that we write include libraries, AVR interrupt libraries, then perform INT main. So first make a output port C. Okay, so here we make C.3 as an output, then port D. Okay, so here we just pull up activated, then read a values of GICR for INT 0, then set interrupt and wait over here. So whenever this INT 0 is equals to 0, for that durations perform this kind of operations, complement the third bit. So this is how we can perform external interrupt programming in C. Thank you.